Dear students, today we are discussing about application of integration. Before starting application of integration, let's discuss about the difference between differentiation. What's the differentiation and what is integration? In differentiation, we are given a function and we have to find the derivative of the function. In integration, we are to find a function whose derivative is given. And the second one, the derivative of a function when it exists is unique. And the integration of a function is not unique. However, any two integrals of a function differ by a constant. Next number, when a polynomial is differentiated, its degree is decreased by 1. Yes, the derivative of x square is 2x. You know that the degree is decreased by 1. When a polynomial is integrated, its degree is increased by 1. Integration of x square is x cubed by 3. The degree is increased by 1. Similarly, we can find the derivative at a point. We never find the integral at a point. Instead, we can find the integral of a function over an integral on which the integral is defined. Similarly, geometrically, derivative of a function represents the slope of the tangent. Slope of the tangent. We are discussing about geometrically. Derivative of a function represents the slope of the tangent to the corresponding curve at a point. Geometrically, the indefinite integral of a function represents a family of curves placed parallel to each other having parallel tangents at the point of intersection of the curve of the family with the lines perpendicular to the axis representing the variable of the integration. Next, the derivative is used to finding some physical quantity like the velocity of a moving particles when the distance transverse at any time t. The integral is used in calculating the distance traveled when the velocity at time t is known. Derivative is used to measure the rate of change. Measure the rate of change of some physical quantities. Integration is used to find the family of quantities which changes in the given rate. In this way, we can find the difference between differentiation and the integration. Now, the second part, let's discuss this question. Find the area bounded by x-axis and y square equal for x minus a and the ordinate at the point hk. Now the solution for this question, dear students. Here we have given y square equal for a x minus a. Then when y equals 0, then x minus a equals 0. If this is 0, for it divided, that's 0, x minus a is 0. This implies x equal a. So we find the area between the ordinates. We find the area between the ordinates x equal a and x equal h. You can see another point is hk and this point is a comma 0. That's why ordinates are x equal to a and x equal to h. Now the required area then the required area equal integration of a to h y dx equal integration of a to h. What is y? From here we can find root under for a x minus a dx. Now we have to integrate this under this condition. This equal root under for a is 2 root a. We have taken out this, then integration a to h, that it remains x minus a to the power 1 by 2 dx. Yeah. Now 2 root a times, what is the integration of x minus a to the power 1 by 2? Simple. X minus a to the power 3 by 2 times over 3 by 2. One more step we have done in this way, a to h. In the next step, dear students, 2 goes up, 2 to the 4, 4 root a over 3. This 3 goes down, and here remains x minus a to the power 3 by 2 whole a to h. Yeah. Then we have to put the value of the x. This is the definite integration. 4 root under a over 3. Then we can put the value. H first. H minus a to the power 3 over 2 minus, let's say if we put here 0 0 a minus a 0 times all will be 0. So finally we obtain the result 4 root a over 3 h minus a to the power 3 by 2. This is the required area. In this way we can solve this question. Now the next question, dear students, next question goes like this. Find the area enclosed by the x-axis. Find the area enclosed by the x-axis of x-axis and the following curve. For this, we have given the curve edge y equal x square minus 8x plus 15. Firstly, we can solve this question, and using GeoGebra also we can find the area. We can check the area. Yeah, let's begin. The solution. Here we have given y equal x square minus 8x plus 15. Yeah, so we have to put y equal 0 to find the points on the x-axis. Then it becomes 0 equal x square minus 8x plus 15. We can factorize this. We'll get the factor as x minus 3 and x minus 5. And from this solution we can find x equal 3 or x equal 5. After finding these 2 points on the x-axis, we find the ordinates. Yeah. So the required area equal integration of 3 to 5 y dx, integration of 3 to 5, what is y? X square minus 8x plus 15 dx. After this step, we can move to the next part, that is we have to integrate this. So for this part, Integration of x square x cube by 3 minus 8x is 8x square over 2, yeah, plus 15x from 3 to 5, yeah. Then we have to substitute the value of upper limit as well as lower limit. Then firstly we have to put the value of upper limit, that is 5q over 3 minus 8 times 5 square over 2 plus 15 times 5 minus fb minus fa is 3 cube. This value we have to substitute, 3 cube by 3 minus 8 times 3 square over 2 plus 15 times 3. Okay, you can use your calculator, then you will obtain 125 over 3 minus 100 plus 75 from this part. 5 5 25, 2 4 we can cancel here for this, and plus minus minus, that is 9, and 2 4 3 3 9 4 36, minus minus makes plus, plus minus minus, that is 45. While solving all this, we will obtain minus 4 by 3 value. If we solve this, we will get minus 4 by 3. But the area is in positive form, or that is never negative. That's why the required area equal 4 over 3 answer. In this way, we can solve this question. Let's try to find the shape of this equation. Yes. Now we can see the curve y equal x square minus 8x plus 15. Here I have shown the equation of the curve. Show the area two ordinates passes through the point 3 comma 0 and 5 comma 0. The area enclosed by two ordinates x-axis and the curve is this, which in downwards, or I mean below the x-axis. So we obtain the negative area. So to make it positive, we have to begin with minus y, or at last we can make it plus. So here you can see this is below the x-axis. So this is the nature of the curve as we have find the area, which is 4 by 3. Yes, we can see this. Now very interesting question, dear student. In the same instruction we can find the solution. Here we have given a curve y equal x minus 1, x minus 2, x minus 3. We have to solve this equation, and we have to find the area enclosed by x-axis, curve, and ordinates. Yeah. So firstly we have to solve this. To find the value of x, we need to put y equal 0 to find the points on the x-axis. Then all these x minus 1, x minus 2, and x minus 3 gives, then x minus 1, x minus 2, and x minus 3 equal 0. It becomes like this. And from the first, either x minus 1 equal 0, that implies x equal 1. Similarly, x minus 2 equal 0, x equal 2, x minus 3 equal 0, that is x equal 3. Then the required area equal, it's very interesting, 1 to 2 and 2 to 3 all are in x-axis. So the required area we can find from 1 to 2 y dx plus 2 to 3 y dx, dear students. That is supposed by I1 plus I2. Okay, first integration, first part and second part we have to add, then only we can find the total area. Now from the first I1 equal integration of 1 to 2 y dx equal integration of 1 to 2 x minus 1 x minus 2 x minus 3 dx. Then okay, from 1 to 2 we have to multiply this x cube minus, if you multiply x minus 1 x minus 2 x minus 3, what will you obtain? We obtain x cube minus 6x square plus 11x minus 6 dx. You can find the separate production of this and you will obtain this result that I have already done. Yeah, now we have to integrate this. Integration of x cube is x to the power 4 over 4 minus 6x cube by 3 plus 11x square by 2 minus 6x from 1 to 2. Then we have to substitute the value, that is fb minus fa. So 2 to the power 4 over 4 minus 6 times 2 to the power 3 over 3 plus 11 times 2 square over 2 minus 6 2. This first part minus fa. 1 to the power 4 over 4 minus 6 times 1 cube over 3 plus 11 times 1 square over 2 minus 6 times 1. We can do this. And after the calculation of this, you can try and you'll find the result is 4 minus 16 plus 22 minus 12 minus 1 by 4 plus, that's 2 minus 11 by 2 plus 6. And from solving this using calculator, simply you can find 1 by 4. First part is completed. Okay, now we have to move to the second part. Now I2 equal integration of 2 to 3 y dx equal 2 to 3 x cube minus 6x square plus 11x minus 6 dx. I have kept the multiplication part. Okay, after multiplication that we obtain this result, so I kept here. Now we have to integrate this x to the power 4 over 4 minus 6x cube by 3 plus 11x square by 2 minus 6x. That's the 2 from 2 to 3. Now you have to substitute the value of 3 here and 2 here. Yes, this 3 to the power 4 by 4 minus 6 times 3 to the power 3 by 3 plus 11 times 3 to the power 2 by 2 minus 6 times 3. One part is fp minus fa. 2 to the power 4 over 4 minus 6 times 2 to the power 3 plus 11 times 2 to the power 2 minus 6 times 2. And finally we will obtain the result like it's 81 over 4 minus, it will be 54 plus it will be 99 over 2 minus 18 plus minus 4 minus plus 16 minus 22 plus 12. Finally we obtain the solution is 1 over 4. Still we have not completed. The area is in negative form, that's why we should make it positive. Area is in never negative, that's why the required area equal I1 plus I2, that is 1 by 4 plus 1 by 4, that is 2 by 4 is 1 by 2. This is the answer. Now let's observe in the figure as well. Now you can see the curve of the function y equal to x minus 1, x minus 2, x minus 3. Here is the curve. Here 1, this point is 2, this point is 3. So these two areas are equal, half and half. Exactly that it we obtain this 2 to 3 is negative, 1 to 2 is positive. If we find 1 to 3 directly, then we'll get a different result that you can check, because if the area is in different direction, you will find zero result. This and this will be zero if you obtain directly. So differently we have to calculate, and finally we have to add the area to find the required area of the curve. Now the next question, dear students, the instruction is like this: find the area of the region. Find the area of the region. Find the area of the region between, between the curve y square equals 16x and the line, what's the line is y equal to x. We need to find the area enclosed by these two line and the curve. Show the solution, and we can solve these questions numerically first, then we can observe using GeoGebra in a real sense. We will find. So before solving this question, you need to check. Here student, we need to check using this diagram. Y square 16 is like this, like this, and the line y equal to x will be like this. We need to identify which one is upper and which one is lower. This curve is y square equals 16x. This line is y equal to 2x. So which one is up? First, y square 16 is up and y equal 2x is down. So y2 minus y1, which one is first and which one is second? That is, it is first and this is second. We have to judge in that way first, then only we can solve the question. Now we solve the two equations, that is y square equals 16x and y equal to x, because we need to find the intersecting point of these curves of the line. Now you can substitute the value of y equal to 2x here in the first case. So while putting the value of 2x in first case, that is 2x whole square equals 16x. This is 4x square minus 16x equals 0. Or you can take common 4x. Here will be x minus 4 equals 0. So either 4x equals 0, therefore x minus 4 equals 0. In the second case, x equal to 4. Here we find the points 0 and 4. Here 0, maybe here this will be 4. Now after finding this point, dear students, we need to find the required area. Required area, that is the integration of 0 to 4 y1 minus y2 dx. Yeah, y1 minus y2 dx equal, which one is first is, I have already mentioned 0 to 4. What is y1? That is y is root under 16x, that is first one is root under 16x, and the second one is y equal to 2x, that's why simply you can put here 2x, that is dx. And after starting this step, we can solve this. Integration of 0 to 4 root under 16x is, that is 4 root x minus 2x dx equal, yeah, first one is 4x to the power 1 by 2 means x to the power 3 by 2 over 3 by 2 minus integration of dx is 2x square over 2 from 0 to 4. Then after this we can put the value at 0. We obtain 0 result, just only you can put 4. So it is, it 2 goes up, it becomes 8 over 3 times 4 to the power, here x is replaced by 4 to the power 3 by 2 minus 2 times x square is a 4 square over 2 minus 0 by putting 0 value. Here from the calculation of these we will get 16 by 3, that is 5 over 1 by 3 answer. The area is this. Now we can see this in real graph. Okay, now we can see the graph of these two equations. One line and another is y square equal to 16x, that's the curve. Here you can see, yes, I'll make is this one. This is the equation of line y equal to 2x. Then this is the curve, that is y square 16x. They meet at the point 0 and this point is 4, and we need to find the area from 0 to 4. Yes, here we have to find the area from covered by x-axis, the line, and from 0 to 4, and 0 to 4 and the curve minus area up to the line, then you will get this area, middle one. So from y2 minus y1 we obtain the result. That's why y2 is which one is upper, that is y2, y1 is this one, x square minus 16x, and y equal to 2x is the first one. And in this way we can find the required area. Here you can see the diagram perfectly. Okay, dear student, now we have to move to the next question. Next number, where is given, we need to find the area of the curve, that is y square equal 4ax and the line x equal a. Very interesting question. The solution for this question is here. We have given y square equal to 4ax. Then we need to find the points, to find the ordinates. Yeah. Oh no, points in the x-axis. So we have to put when x equals 0, then y equals 0. X-axis 0, this is 0. Show the curve passes through the origin, that is 0, 0, yeah. And the curve y square equal 4ax is symmetrical about x-axis. You know, symmetrical to x-axis means like this, divided into two parts, yeah. And this is y-axis, and the figure will be like this, yeah. This is x equal to a line, yeah. The area, then the area of the curve and the line is, that's if we have given O, this is A, this is B, and down one is also C. So the line is x equal to A. It cuts the curve in both sides, down and up. So the area equal from OCBO, that is OCBO, that is the area of OCBO. Yeah, that's OCBO is 2 times of OABO, 2 times the area of OABO. Here you can write area of OCBO first. Yeah, so the second part is 2 times, because up and down is symmetrical, that's why that is equal. So you can write 2 times integration of, it is passes through origin, and x equal to A, that's why 0 to A, yeah, y dx equal 2 times integration of 0 to A root under 4ax. The equation is y square equal 4ax, that's why this is root under 4ax. Then the root under 4 is 2, 2 to the 4, here 2 and 2 is 4. Integration of 0 to A, A also we can take out, yes, yes, one more step, yes, root A, integration of 0 to A, root x dx. Yeah, now we can find the integration of this 4 root A, that's root under x is 2x 3 by 2 over 3. That's, we have done this many times, and 0 to A, and finally the answer is 4 root A 2 times A to the power 3 by 2 by 3 minus, that's 0 means 0, that will be 0, we will not try that. Its product, that product will be 0. So I have written directly 4 to the 8 is a to power 1 by 2 and a to power 3 by 2, that will be a square over 3 is the required answer. Now we can observe this graphically. Okay, now you can see the graph of y square equal to 4ax and x equal to A. Here I have taken the slider, A value is movable, that's why here I have taken value 1.5 or 2, it depends on that. Anyway, it becomes like this. Yeah, so the area enclosed by this is double or upper one, because the curve is symmetrical. Y square equal 4ax, if A is 2, that will be y square equal to 8x. It shows like this, that's why you have to find from 0 to 2 the area that we practice, 0 to 2, and the ordinates and the curve, but here it is double, that's why you have to enclose both area, including both area, that's why 2 times the upper of first quadrant A is the required area in this case. Now I will discuss the next question, dear students. Before solving that next question, let me highlight, highlight the nature. Let me show the nature of the curve. That, suppose we have given, this is the equation y square equal x cube. Here shown minus x cube plus y square equal to 0. So y square equal to plus x cube. Then another line is x equal to 4. The enclosed area by this curve and line will be like this. In the previous question that we have double this area, upper area. That's why here also, before solving this question, you have to find whether the equation and the line, in what ways they will intersect, or in what ways they will enclose the area. So they will intersect at the points 0 to 4, and the area will be double, which is shown 0 to 4 integration of this part, upper part, it will be double, and the same way you can solve the given question is y square equal x cube and the line x equal to 4. The line is x equal to 4. The equation is y square equal x cube. You can solve from the observation of this diagram. Now, dear students, I will show the another curve. I will show you another curve that both are curve. The curve is y square equal to 4ax and x square equal to 4ay. Is y square equal to 4ax? Yes, we have taken a is 1. Then y square equal to 4ax. You can see the curve which is up. That is supposed by equation 1. And the second one is x square equal 4y. X square equal 4y is symmetrical about y axis, and y square equal 4s is symmetrical about x axis. Both are intersected at point 0, 0 and x equal 0. Then we need to find the area enclosed by this. In this case, you need to identify the curve which is symmetrical about x-axis is y square minus 4x, that is open, or y1, and another is y2, and we need to find the area enclosed by them. The diagram is clear over here. Now I will solve this question by the numerical way. Just now we have shown the graph of the curves, that the question or curve are y square equal 4ax and x square equal 4ay. Yes, shown in the graph, the figure will be like this. This is symmetrical about x-axis, this is symmetrical about y-axis, and this will be the area enclosed by both the curve. We need to find this. This point is 4 and this point is 0, 0. Yeah. So the solution for this question, dear students. First, here we have given the first curve y square equal 4ax and another is x square equal 4ay. Then solving to equation, now we can put the value of y from the second one. From second one we can put the value of y, that is, what is the value of y? This implies y equal x square over 4a. Now what is the value of y? We can put here, that is x square over 4a whole square my equal 4ax. Yeah, so it will be x to the power 4 over 16a square equal 4ax. Or simply you can multiply this x4 equal 16 4 64 a cube x. Yeah, or x4 minus 64 a cube x equal to 0. Or simply we can take x common, it becomes x cube minus 64 a cube equal 0. Then either x equal 0 or x cube minus 64 a cube equal 0. You will guess the value of x is like this: x cube equals 4a whole cube. Therefore taking positive, that's we will get taking positive cube, that is x equal 4a. Then we have to find the required area, dear students. Yeah, therefore the required area equal integration 0 to 4a y1 minus y2 dx. Yeah, then that is integration of 0 to 4a. What is y1? The y1 is root under 4ax minus y2 is x square by 4a dx. That is, two equations are these. So integration of these two we have to find. One more step, 0 to 4a, you can write that is 2 root under a, 2 root under a x to the power 1 by 2 dx minus 1 by 4a x square dx. In this way we can manage this part. Then finally the integration of this is 2 root a times x to the power 3 by 3 by 2 minus 1 by 4a, that is x cubed by 3, that is from 0 to 5. Now you are familiar with this term and terminology. You can solve other steps and finally we'll get the answer is 16 over 3 a square. I will not, these steps you can do yourself and find the answer of this way.